Right now, a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system.
What extraordinary timing! A rare and astonishing event is unfolding. 3I Atlas is passing close to Mars. As of October 4th, 2025, the object is now drifting away from its nearest approach, yet it remains close enough to capture scientific interest. Just a day earlier, on October 3rd, it reached its closest point to the red planet. From Earth, though, observing it is nearly impossible at the moment. The sun's overwhelming glare hides it completely from view. That means our only clear perspective comes from the spacecraft currently orbiting or exploring Mars. Ironically, several NASA sites and live feeds have gone dark due to a government shutdown right when real-time updates matter most. It feels suspiciously convenient that public access is restricted during such a crucial interstellar encounter, especially as scientists worldwide scramble to study what could be the strangest object ever detected in our solar system.
When 3I Atlas was closest to Mars at a distance of 30 million kilometers. The challenge there is that NASA is currently under government shutdown, and so we cannot get any communications from NASA, and that prevents the flow of data that was already obtained.
Speculation is already running wild. Some believe it could be an unusually active comet, unlike anything previously observed. Others go further, wondering if it might be an interstellar probe, an artificial device, perhaps even an alien craft. Regardless of what it turns out to be, the timing of this information blackout is raising serious questions. Thankfully, there's a promising clue. On October 2nd, NASA's Perseverance rover captured a faint streak during a multi-minute exposure sequence. This streak doesn't match the usual patterns of Mars's night sky. Rather than aligning with the vertical star trails caused by the planet's rotation, it cuts across at an angle consistent across several frames. In other words, it's real. It's not a glitch, it's definitely moving and fast. It's entirely possible that what we're seeing is 3I Atlas itself. Credit goes to Drew, whose sharp observation and post on Twitter sparked a deeper investigation. The object's true size is still unknown, though early estimates suggest it's at least 5 kilometers across, potentially even larger. Interestingly, it doesn't have the classic dramatic dust tail of a typical comet. Instead, it appears to be surrounded by a massive, faint halo, a diffuse cloud of ionized gas and dust. Its velocity is astonishing, racing through space at about 60 kilometers per second and projected to accelerate to nearly 68 kilometers per second as it reaches perihelion toward the end of October. Around September 25th, a coronal mass ejection from the Sun collided with the object, possibly charging or energizing its outer layers. Subsequent observations on September 27th and October 2nd revealed no dramatic disruptions, no tail disintegration or fragmentation, just a slow, steady expansion of its gaseous envelope. That's why NASA's coverage blackout hits so hard. This was a moment the world wanted to witness in real time. Fortunately, we still have eyes in the sky. ESA's Mars Express and the ExoMars Trace Gas Orbiter were both positioned to capture the object's close pass, collecting detailed imagery and gas spectral data to analyze its motion and composition. Even the JUICE mission is set to cross paths with it as it nears the Sun. However, solar interference will delay communication between the Sun and Earth, meaning we'll have to wait for most of that data. Still, when combined, these European spacecraft could give us our clearest picture yet of 3I Atlas. For now, all attention turns to the ESA, our best hope for the next breakthrough image.
The European Space Agency released the data from ExoMars camera on one of its orbiters of Mars, and it looks like they detected the interstellar visitor, 3I Atlas.
Determining the true size of 3I Atlas isn't simple. Measuring a comet's actual dimensions is tricky because its solid core, or nucleus, is hidden within a glowing cloud of gas and dust known as the coma. As a comet nears the Sun, its icy surface vaporizes, releasing gas and dust that form the bright halo and long tail we associate with comets, often making them appear much larger than they really are. A research team from Harvard, led by Richard Kluter, Avi Loeb, and Peter Varesh, tackled this challenge by analyzing data collected between May 15th and September 23rd from 227 observatories around the world, coordinated through the Minor Planet Center. They compared the comet's observed motion to the trajectory it should have followed under pure gravitational influence.